All right, guys. Operations with complex numbers. Here's the quick of it. Going through a little bit of each, so pay close attention. The one thing to memorize, I squared is -1. You know that for the rest of your life. Tattoo it on your arm. Okay? Now, simplifying these different things, we have addition, we have subtraction, and then we have some multiplication, and then we have some division. Okay, so we have a few different things going on. First, the addition one. If it's addition, I'm not too worried about addition. We just combine like terms. -4 plus 4, that would be a big 0. 1i plus -6i would be a -5i. And so we would just write -5i. Now this is a little bit rare to have 0 here. Usually it's like a 8 minus 5i or something, but that's what it happens. So subtraction, a little bit different. We have to distribute the minus. Technically we're distributing the plus, but honestly, when you distribute a +1, what happens? Nothing. So if we distribute the minus, that's a -8 and a -3i, and now 4 minus 8 is -4. 4i minus 3i is plus 1i. And there we go. So real simple with adding and subtracting, not a big deal. Multiplying is a little different. Now, in my one class, we wanted to distribute, and that's all good. I'm going to show you how to do it with distributing, and if you prefer the box, I'll show you that as well. But we're multiplying these. You know it's multiplied because they're right up next to each other. And so -5 times -4, -5 times -2i. So -5 times -4 is 20. -5 times -2i is plus 10i. Then we go -8i. -8i, it's a negative, times both of those. So -8 times -4 is a positive 32, and there's an i. -8 times -2 is a positive 16, and there's an I squared, because I times I. Now this is where the I squared equals -1. This is -1, and -1 times positive 16 turns it into a -16. Now we can combine like terms. 20 minus 16. The I squared is gone because we made it -1. So that's 4. 20 minus 16. 10i plus 32i is 42i. And we're done. Now, this next one is multiplication as well, but it's a squared. Please remember, don't be a doof-and-cough to square this, and be done. Please remember that this means that -7 minus 6i is times itself. That's what squared means. So it looks like that. And if you should so choose, you could organize your work inside a box, and that's all cool. -7 minus 6i, -7 minus 6i. We'll go green here. That's going to be -7 and -7, 49. -7 times -6 is 42i. This will also be 42i. And this will be 36i squared. You're just organizing your work rather than listing it out like so. You're organizing in a box. Good for you. But I squared is -1, so we can cross it out, and this becomes a -36. Now, 49 minus 36, those are going to be like terms. 49 minus 36 is 13. And then 42 and 42 make 84i. So if you would like to organize in a box, you're welcome to. If you'd like to distribute, you're welcome to. Move on to division. Now, with division, we get a few different things. These first two, I'd like to highlight that we have a monomial. A monomial, a single term. These other ones are binomials. Little definition there. When it's a monomial, I don't have to do too much. Okay? I don't have to multiply by what we call the conjugate. I have to just multiply by I over I because of this. It gives me negative 7i over negative 5i squared. But the I squared is negative 1, so it will change this negative to a positive, and my answer will be negative 7i over 5. Done. Let's see that one more time. I have a monomial. I do not need to multiply by 7i over 7i. Just the I will do. Now, in this case, this I is going to have to distribute on top. There's two things. But it will give me a negative 4i minus I squared over a negative 7i squared. Now, if you cross out those I squared, shame on you. That's just killing a puppy. I squared is negative 1, so we're going to cross this out, make this positive, but I got to put a 1 in there. We're going to cross this out and make this a positive. So now I have negative 4i plus 1, because I squared was negative 1, so it becomes 1, make that a, and this will be over 7. The only thing I don't like is the 1 and the 4i should be switched. We write complex numbers a, then bi. So the I comes afterwards. So I'm going to write 1 minus 4i, a minus bi over 7. And now we're good. So monomial, we only have to multiply by I over I. When it is a binomial, now I need to multiply by the conjugate. And the conjugate of the binomial is simply taking that binomial and changing the middle only. Changing the middle. Now, get this. We're going to distribute here. This is simple because I got a monomial on top. And the numerator never is an issue. It's the denominator. So 2i times 2 is 4i. 2i times 3i is plus 6i squared. We're going to have to change that. But get this. Every time I have conjugates, 2 minus 3, 2 plus 3, a minus b times a plus b. Every time I have conjugates, it will always be the first one squared, the second one squared, and subtraction. There's no middle term. It's difference of squares. Conjugates are difference of squares. So what is 2 squared? 4. What is 3i squared? 9. I almost wrote 3. I squared. And then we subtract. So 2 minus 3i times 2 plus 3i become 4 minus 9i squared. Only because of difference of squares. Otherwise, I should do a box or distribute. I squared is negative 1, so this becomes a minus, this becomes a plus. Because we're negative 1 times that, so 4i minus 6, I don't like that. 4 plus 9 is 13. I'm going to change that to negative 6 plus 4i over 13. Just changing the order, putting the constant first and the imaginary second. And then I'll get my answer. All right, let's try that one more time over here. Let's kind of create off a little boundary. Multiply by the conjugate. What is the conjugate? Press pause and figure it out. The conjugate is 5 minus 2i. Now, technically speaking, we should have parentheses everywhere. So let's multiply this out. Negative 3 times both of these. That'll be negative 3 times negative 15. Negative 3 times negative 2 is positive 6i. Now we're going to take negative 7 times both of these. Or, I'm sorry, it's a positive 7i. So plus 35i and minus 14i squared. Now we're going to multiply 5 plus 2i, 5 minus 2i, so that's 5 squared minus 2i squared. Difference of squares. Difference of squares. I squared is negative 1, so it makes that one plus and that one plus. Negative 15 plus 14 is negative 1. 6i plus 35i is 41i. And 25 plus 4 is 29. If I can reduce, I want to. But if you reduce, all three numbers must reduce, not just two of them. Lastly, graphing. Graphing is actually kind of easy. Every single imaginary can be thought of as an ordered pair with A and B, like X, Y. And it's this first part, this A, is my real part, and my B is my imaginary part. And so when we look at the graph and it says real and imaginary, the real is my A, the imaginary is my B. And you can think of it as an ordered pair, like X, Y. So negative 3 plus 4i is very similar to just saying negative 3, 4. It's not saying that, but that's how we will graph it. And so we'll go here and we'll go, oh, negative 3 plus 4. And there it is. It's going to go over negative 3, up 4. And you see the numbers. That's how we graph it, just like that. The only tricky ones, I'll add a couple in here for you. What happens if I have just a 3? Or what happens if I have let's go negative 4i? Well, if you consider that these have to be written like this, then 3 is really saying 3 plus 0i. And 4 is saying 0, not plus, minus 4i. In other words, part of my a plus bi is a 0. And if I think of that, then I will think of this as 3, 0, and this as 0, negative 4. And so it will be graphing as 3, 0. This is where 3 is. And 0, negative 4, 1, 2, 3. This is where 4i, negative 4i is. So each ordered pair should be considered graphing as if it were an XY. So what is this? Well, this goes negative 4 on the real, and real is the first number, and then up 1 on the imaginary, and imaginary is the second. So we get negative 4 plus 1i, and there you have graphing.